Well, the floor is yours, Fernando. Take it away.
Cool. Morning, everybody. Sean and Julie asked me just to talk a little bit about Docker, when you might use it, what it's used for, that sort of thing. I'm trying to find where I share my whole desktop here. Let's see. Desktop one, where's it at? Browser. I should be able to share my whole desktop, right? Isn't that an option?
I thought it used to be.
A lot of options for different apps. All right, let's see if I can do this with preview then. It's going to be a little janky. All right, so hopefully you can see just one very simple image on the screen right now. Cool. So I'm going to just give you like a basic scenario of developing some stuff and when you might want to switch to use Docker in addition to the development. So this is a little bit of a stretch because hopefully your development environments don't really look this bad, but it's for illustrative purposes more than as an actual scenario that you run into a ton. So let's just say you have one machine that you can host software on. Maybe it's your laptop, maybe it's a virtual machine that your IT department has given you, whatever it is, you only have one machine to work with. And as a Python developer, someone asks you to write, a script that processes some data, or it has some functionality that someone wants. And so you end up with something that looks like this image, where you have a couple Python files. Maybe you've installed some requirements like the requests library or something like that. And maybe you're importing a few things from the standard library. So that's all well and good. Everyone likes your simple program that you've written. And suddenly they're like, oh, this guy knows Python. This person knows Python. Can you write me a script that does something else entirely and host it on your one machine? So because I can't share my whole desktop, I'll just go to the next image. Hopefully you can see two Python applications now. So you've got your original application, A, B, and C. They are, using your libraries, and then this second script that you've written now lives here in D, E, and F.py. Again, maybe you've installed some libraries. For the case of this example, let's again say you also use the request library. So both of these tools that you've written, the first one and the second one both use requests. Great. So now you've got two pieces of Python software running on your one server. And people see both of these programs that you've written and they say, wow, this person really knows how to write Python. And we really like these two tools you've written. Can you put that on the web somewhere so that we can run your tools without having to install them or without having to really know much about them? Can you just put a web form in front of it to do this stuff? So you say, okay, I've got one machine, I know how to write Python, so I will put a web server in front of it. Where's my third image? And now it looks something like this. You've got your your first software, the second piece of software you wrote, and now you've got this web app.py. And because web apps always seem to come with a database for whatever reason, now you've got a Postgres instance installed as well. This is still all on one machine. For the sake of this example, we'll say you didn't use virtual env. I don't know how clean all your environments are. I know when I got started with Python a long time ago, I never even heard of virtual env. So I just installed all my requirements to, the standard locations and thought everything was good. So we'll just go with that for the sake of this illustration. So now you've got these three sort of independent pieces of software. One of them is a web app that has a database. And because now it's a web app that people want to access, now this server has to be put out, somewhere on the network where people can reach it. As a side effect of that, because you also have a database now, the database is also out on the network that can be reached through other ways than just your web app can. So you've got 3 pieces of Python software exposed now and a database. So let's say for your web app, you decided to use Django or Flask or any of these, it's a web app framework essentially that provides you a bunch of functionality out of the box. So you don't have to write everything. You just make a bunch of function calls and you've got a website. Well, what happens when Django or one of these other libraries needs you to upgrade one of the packages that you've installed? We'll say requests. That's not really a good example if you're using Django, but anyway, let's pretend your web app, for whatever reason, needs a newer version of the request library than anything else that you've written over here. All 3 of them are using it. They're all using the same copy. And so when you update it, there are breaking changes, and now these other 2 pieces of software stop working. Or let's say you're really on the ball, or someone else has come in and taken over this piece of code because you're now busy over here. You don't have enough time to work on all 3 pieces of the software, whatever it is, and they're really on the ball. And you wrote all this in Python too, because that was, let's say, the native install on your Mac, and so you just went with it. And so this person over here who's now working on A, B, and C, they say, well, Python 3 has been out for 5 years now, or however long it's been out for. So we're going to Python 3, but unfortunately, you still only have this one machine that you're allowed to run the software on for whatever reason. So now you get into this world of you have to manage different Python versions. You might have to, you have to start investigating, oh, maybe I do need to start using virtual M's because I need a different version of requests on this one than I need over here, or whatever it is. You start getting into this sort of spaghetti of, I have to manage these dependencies that are all installed in one place. They're all used by all these different files, but updating it in the global install breaks things, over here, or breaks something over here. Well, this gets very messy very quickly. As you can see, I've only got 3 applications, and I'm already in this world where I've got a database exposed to the entire world. I've got these dependencies that are sort of a mess because I failed to manage them up front. What can you do to make this simpler and easier to manage? And that's where Docker comes in. What Docker is, I don't know what the official definition of what Docker does is, but I sort of see it as a wrapper to the software that you're writing. So what Docker ends up making it look like is this. Oh, can you see that? Yeah. So what you end up with in Docker is you sort of have your original software and the libraries you installed, and it sort of, you build all of the components inside this wrapper called the Docker container. So you have your A, B, and C.py, you have your request library, you have a Python interpreter, and that's all packaged within one Docker container. For the second piece of software that you made, you've still got DE and F.py. You can still install whatever libraries that you needed for your requirements, and you still have its own copy of the Python interpreter and the standard libraries. Just as an illustration, this Docker you can build pretty much any software into Docker. It's not just for Python. So maybe you have your Postgres container also goes into Docker. So this is all still on one machine, but now all of your dependencies are kept separately. You can upgrade them as you want. You can upgrade the Python version, and it's not going to impact any of these other containers that you have running on the same machine. One other neat little thing that it adds is virtual networks. So again, if we're assuming that all of this stuff is on one machine and you had to expose it to the internet or to the network or wherever you have to expose it to get your web app to run, you might not necessarily want people to be able to directly interface with your database. So one nice thing about Docker is you can create private networks. So even though this whole machine, this like the entire graphic here is connected to the internet, you can set it up such that the database actually isn't reachable from the internet. It's only reachable from your one container that you want to be able to access the database. So that's another nice little piece about Docker. Firstly, I want to say containerizes, but that's just sort of a Docker term. It bundles all your requirements into a package that's portable and easy, and it also allows you to control what stuff is reachable from the network and what stuff is reachable from the wider internet. So this is the very high level overview of what Docker does. And so how does it do that is the question, or how can you get there? So we went from all of the components are just all in one place to we have these sort of separate components for each application that you wrote. And you really want to get from A to B, from all components in one place to all components sort of in their own nice little clean wrapped up world. You really only need to install Docker and to write one file. So if I show you a Docker file real quick, let's see. Or let me step back before I show you a Docker file. I'm going to show you an example of a Flask application, which is Python web framework. That would illustrate this piece. So I go to my share button. Let's see. So here I have a Flask app. I think you can see my Visual Studio Code. Maybe I'll make it a little bigger. Sure. This is a Flask application. I'm not sure how many people on the call are familiar with Flask, but basically you have your HTML templates. You have some static content, some graphics. Looks like your CSS file. You have a little bit of config. And then you have your actual Python files that run the application. So this has, your standard requirements.txt. So anything that your software requires goes in here. And then you just have, we call it boilerplate for a Flask application. So how do I get that in Docker? Well, Docker has these things called Docker files. It's essentially an instruction set of what to do with all these files that I have in this directory to make it into a nice wrapped package. So the first line of a Docker file tells you what image. I guess I should talk a little bit more about what a Docker container is. A Docker container is not quite a VM, so it doesn't have everything that you need under the sun. It just has enough to run whatever distribution you like. So this could be from Ubuntu. Maybe you've heard of the Ubuntu Linux. There's probably a Mint Linux one. I don't like Mint Linux, but there's probably an image for it. So basically the first line of your Docker file is what is the baseline of the system that I need to run this software. There's a distribution called Alpine Linux, which is just essentially like super minimal. I think Alpine Linux is like 5 megabytes or something like that. So it really only has the bare bones required to say this is a Linux distribution. If you look at the official Docker documentation about writing Python, I think they usually say, start with the Python distribution or the Python image. There might be a Python 3 image. Much like everything else in software development, there's like 10 different ways to skin every cat. So our team just happens to use Alpine for everything because we like to keep things super minimal. One benefit of this is that you read sometimes about all these software vulnerabilities that come out and it says, oh, the C compiler has this vulnerability where some hacker can come in and overflow the stack on the compiler or whatever they're doing and inject some code. Now they've got access to your system. Well, one advantage of using Alpine is none of that stuff is installed out of the box. So the attack surface for your Docker container is just super small. There's minimal tools on it. There's not much you can take advantage of. So the first line of your Docker file is from some baseline. And then from that baseline, in our case, Alpine, we're going to expose port 8000. We're going to install Python 3. We're going to copy our app files over there. I don't see a public, I'm not sure what this step does. This is not my code. I'm just using it for example purposes. And then you're going to run, your pip install to get your requirements. So you've got your application files, and now you've installed your requirements for your application. You can set up your Python path. I'm sure you've run into that working on various Python code. And then you specify a command that this Docker container is going to run when you run the application. So what this is going to do is run gunicorn. Maybe you've heard of that. It's a WSGI server. And it's going to initialize this application that we're looking at over here. So when I run this, let's see, I probably have it saved. When I run docker build, this command right here, it's going to step through all these things. It's going to download this, baseline image from Docker Hub, which we'll talk about in a second, or from wherever. There's a lot of configuration in Docker. I'm going to skip over. I'm not actually pointing to Docker Hub. I'm pointing to this Docker registry that we have set up. So when you run docker build, you can run it without this -t. You can just run, let's see. You can just run docker build with a path. And since I'm in the directory with the Docker file, I can just put a period here for relative path, and it's going to build the Docker file that's in this directory right here. If I run it without a tag, you'll see it's building. You'll see it's going through the different steps. It's adding the Python 3 package. It copies over my app files. It installs my requirements there. And then it says, I've written this image with this crazy hash, which no one ever remembers, which is why you use this tag. So it will build, and you can say run this, which doesn't have much meaning to anybody. It's just this giant hash. So a nice thing you can do, where'd my build command go? A nice thing you do is -t, which is tag. And so I'm going to tag this image with a name. It's called on-call demo. So I'll build it again just for fun. And you can see now I've got, it's written this image and it's named it Docker registry.lasp on-call demo. So now I can run it. So docker run is the command you use to run this image. And what it does is it takes the image you just built. I've got this switch in here to expose port 8000 in my local environment to port 8000 inside the container. So when I run this, basically what you get is it's running this command, the last step that you've added in your Docker file. It's saying gunicorn, on port 8000 here, and it's running this Flask app. So when I go to it, here we have our Flask app, nice and conveniently wrapped up, and it's running. So let's say, oops, I want to edit this code. Well, so I can also push that. So I've just built, so with those two commands, or with that one command, really, this docker build, I've just built this container, this Docker container that has all the requirements I need. It has my application files. It has everything you need to run this Flask application. And now it's built to my local machine. So what you can do is you can push that. And so now Docker push, what that does is it'll put it in what's called a Docker registry. And a registry is just a big index of a whole bunch of different Docker images that you've built. Because I'm pushing this to Docker registry.lasp, this is our registry for all the images we built at LASP. But there is also this site called Docker Hub, which is the default registry that you will get if you don't specify a registry. And that just, I'll show you that real quick. It just looks like this hub.docker.com. And so if I didn't specify that I was pushing up to a registry, it would assume, based on your Docker configuration, it's probably going to assume that you're trying to push to Docker Hub, so you'll have to have an account and everything like that. But it'll push it up. If you do Docker push, it pushes it up to wherever you've defined. All our Docker images go here. So we can come back to Docker Hub in a minute, but that is just the default that happens if you don't configure your own. So we saw that when I run it locally, it runs, it spins up on my local machine. So what if I want to make a change? I'm going to go to my application files, and we decide, let's say, someone puts in a comment or a ticket or something that says, this page just really isn't colorful enough. So could you change the, color of the text on the header? We'll just say yellow because I'm just not into best practices for this demo. So I'm just saying, the header is going to be styled with color yellow. So I'm going to save that. And because I want this
Fernando?
to be, yeah, go ahead.
I'm still seeing your Docker Hub. Do you need to switch back?
Oh, yeah, I do. Sorry. Thank you, Doug. Let's see. Yeah, I was hoping to be able to share my whole desktop, but I can't seem to find that option. Where'd my Visual Studio go? Okay, so what I've done is I've changed this to, I need color yellow on this header that says contact the on-call flight controller. So because I've changed the code, maybe I want to call that Docker build, and I want to call it demo v2. It's version 2 of this demo. So we're going to build it real quick. So it's installing, it's downloaded, it's now, copied the app files over. It's installing the requirements for this. And now it's built, Docker registry.lasp on call demo v2. So now if I go and I run, I just have to update my run command to say, now I'm running demo v2. I run that. And now we've got nice yellow text, the ticket is complete. And so I want to push that. Say, okay. Again, I switched windows and looked at my browser, and you could see that the text came up as yellow. Sorry. Again, I meant to share my desktop. I keep going back to that. So anyway, you can just assume this is running yellow text in the header. But why is this so useful when I can just run the Flask command and do the same thing? Well, we'll show you that in a second. So what I'm going to do is I'm going to push my version 2 of this code up to our registry. You can see some of it already existed because only the template changed, and the way Docker builds things is that every step that you define in this Docker file, it creates what's called a layer, so that if nothing changed, in the first 3 steps, it doesn't have to rebuild that the next time. It just says, oh, the first 3 steps are exactly the same. So you see, oh, there's layers that already exist, and it just reuses those. So I just pushed this up to our registry, and let's say, okay, Sean was the one that put the ticket in. I don't want to deploy this to production without Sean giving his approval. So I say, hey, Sean, can you run this v2 version of this application that I just made? Sean, I'm going to ask you to share your screen and just run the command I asked you to look at last week.
I can absolutely do that.
So Sean has not been in on any of the development I've done in the last 5 minutes. He doesn't know about the yellow text. He just knows, he said, oh, it's not colorful enough. Can you make this yellow? And so I just did that. And so Sean can say, hey, I need the test.
Yep. And let's see here. I can run this in my terminal window, and it will be this terminal window right here that I will be using for Volks. Share
And
screen.
I just added V2 on the end of the Docker on the tag there.
So I have my Docker run command and demo, just as simple as running V2.
Uh-oh.
Whoops. It's as simple as doing that once you have the Docker daemon running. Docker is actually an application that you have to have installed on your machine and running to do Docker things.
Right. So there is one requirement, which is having Docker running.
I don't know if that starts up quick enough for me to go ahead and
You might need to
Fire it up.
sudo depending on how you have your setup.
yeah. Docker desktop says it is running. Let's try sudo. Docker registry last. Oh,
Sorry,
I'm not on the VPN.
It's usually
There.
much less painful than this. If you're not on our Docker registry is on the LASP network. So you have to be on the LASP network to be able to run our images in this way. But if you're using Docker Hub, which is the default public Docker registry, this step wouldn't be required.
That makes sense. We manage that Docker registry ourselves, which is why I have to do that. Gotcha. All right, now that we're not watching me log in, one last time, and I'm going to do it without sudo. And look, it starts bringing in things.
Right. So now so with this one command, because Sean and I are both running Docker, and I have pushed this on-call demo V2 up to our registry, he can just run it directly from his machine. It checks it out. It pulls the code down for him, and now it should be running.
Yeah, and I have not seen this on my own machine yet, so this would be pretty awesome if it does what it's
Hopefully I didn't
supposed to
break
do.
something. Let's see here. Did I?
Listening at this port. Hey, there we go. I had to kick it in the pants a little bit. This looks yellow. This does look yellow.
So
we
what you
made
can
a
see then,
change, and now I have it.
so what this illustrates is that I've on my own machine here just made changes to the application. Usually they'll probably be more involved than just changing the color of some text. But say you spent a week on developing some sort of Python changes to whatever code you're writing. All you need to do is push that code up into this registry, and now anybody who can access it can just run it directly from their machine. Sean doesn't have this repo checked out. He hasn't built the code by other means. All he's done is just run the command that says run on-call demo v2, and he now has all this code running on his local machine.
Sure
and so
do.
that is one of the big benefits of Docker, is the portability. Anybody who's running Docker on their machine can run this Docker image and know that it's going to have all the requirements that the software needs. It has the exact interpreter that I'm using. Sean is now running on his machine. It has all the exact same versions of the libraries. Everything that the software depends on is identical between what I just built on my machine and what Sean is running right now. So that's the major benefit of Docker, is you get this wrapped up version. I wrote a Flask application which has, or somebody wrote this. I didn't write this particular application, but it has, several directories worth of files. It has its own dependencies. All that stuff just gets wrapped right up in this Docker image, and it is portable. So Sean can run it. I can deploy this to one of our web servers next to any number of other Docker containers. And other than maybe a port collision if you specify your port statically, maybe if you have two things running on port 8000, you run into some problems there. But Docker brings this sort of requirements and dependency management. It brings portability so that anybody who runs Docker can also run this software that we've developed here at LASP. And you don't have to worry about your own environment getting messed up. You know, like if I go back to the example of, let's see, where's my share button again? If I go back to this example, you don't have, if you have your own Python environment that looks, you know, you have just whatever libraries you need for your own local software, you only have what you need. The Docker container doesn't mess with any of this stuff. It is sort of an encapsulated piece of software. It's not going to touch any of the libraries that you have installed locally. It's not going to try to update any packages that might cause, you know, collisions. We were talking about if you updated the request library and it worked over here, it might break this piece over here. You don't have to worry about any of that stuff because the Docker container is its own encapsulated piece of software. And so that is the big benefit of using Docker. That is unfortunately that's as far as I got when putting this presentation together. And I'm happy to talk about many more details. We didn't go into disk mounts or anything like that. Another thing, let me see if this shows up. Yeah, so another thing you can do, where's my share button again, is you can see, where am I going to do this? Maybe here in Bash. You can see right now, I don't know if you're getting this. You can see right now, if I do Docker PS, this is a command that shows you all the containers that are running on your local machine. So you can see right now I am only running this on-call demo, but it's sort of all within, it's not quite a virtual machine, but it's all within this wrapper. And so maybe there's something going wrong and I want to see, okay, this isn't really installed on my machine. So I need to be able to see into the environment that this stuff is running in. So I can do a Docker exec, and what this will do is it'll execute a command inside a container. So it gives this name. If you don't specify a name, it just gives you a random name for your container. So inside this container, I'm just going to run shell. And so now you can see I'm in the app directory of this Flask application, and I can go in and, you know, maybe I need to, maybe something's not working. I'm like, oh, did all my requirements get installed? And so you can go into the Docker environment and sort of look around, poke around if you need to check logs. What happens when you run a Docker command? If I go back to this other, it would be so much easier if I could share my desktop. I'm sorry. If I go back to this other thing, what usually happens when you run a Docker container is all of your logging info and your standard out and your standard error will just come into standard out of wherever you're running this. So if you don't have logging set up to go to standard out, or your logs generally write to a file, you're not going to be able to see that stuff without inspecting the container a little bit. And so maybe you need to go in and say, well, I need to look at log.txt, or I need to look at some file just to troubleshoot or whatever it is. Docker also provides the interface to get into the environment inside the container and poke around. You can cat your files. You can make sure, you know, your disk mount is there or whatever it is. So you can just exit that, and now I'm back in my regular old command shell. So Docker provides a whole lot more than this. This is sort of the simple use case of dependency management, which is a big thing, and portability is the other. To me, those are the two big things, is I don't have to worry about installing all these dependencies manually, and I don't have to worry about any sort of collision with my local machine because it's all sort of encapsulated. I see we got a hand up. Go ahead. Don't know your name, sorry. B.A. Thomas. Bathamus. I'm not sure who that is, but yeah, if you got a question, feel free.
Hey, I'm Brian.
Go ahead.
It's not really a question, it's more of a comment. I certainly subscribe to all of this, and containerization of software is definitely best practice. I think an issue for us at NASA is a security one, and that is Docker is frowned upon at the agency simply because the base images can't be vetted. They're being pulled from some public space. So one of the things that we've thought about looking at is standing up some kind of vetted container registry for the community. And then that would provide a number of base images that people could pull from and target towards development. Do you think that that would be useful? Is that just kind of in the way, or?
Yeah, definitely. And we've sort of started going down that route. So let me show you, let me go to our.
I want to tack on that to that question actually, because I wasn't 100% clear where these images were coming from. So am I hearing that, like, say if you write Alpine in that one line there, it is being pulled publicly from that Docker Hub website?
Yes. So let's see. Go to my browser. So this is our repository, a registry, Docker registry. We use Nexus for this functionality, and one nice thing about Nexus is it provides more than just a Docker registry. We also have a Python package index here. We have NPM packages, so our front-end developers can develop libraries that we can use. And Nexus will manage a Docker registry, a Python package index, an NPM registry. And I think, so to Sean's question, yeah, by default, if the package isn't available in your private registry, it will go to Docker Hub. So ours says from Alpine. So if you look at Alpine, there's an official Docker image for Alpine. And it's got, you know, a whole bunch of different versions. So if you go back to the command we ran, we said from Alpine 3.7. And so what this format is it's the name of the image you want to run, and then the jargon is it's a tag. So we're running the 3.7 tag of Alpine. Oh shoot, I switched windows again. You're not seeing it, I'm sorry. But ours says Alpine 3.7. It looks like that's pretty far out of date because they're up to 3.14. So maybe that's something I could push after this demo, is just updating this a little bit. But so you could say from Alpine : 3.14.1, 3.12.7, you can get very specific with, I want this version of the Alpine code for my base image. And so for our registry, we've left it so that if the file doesn't exist in ours, if Alpine hasn't been pushed up to our registry, or if a NPM package hasn't been pushed up to our registry, it will fall back. But to Brian's question, you could disable that so that literally only, you know, you could call it, you know, not NASA registry.nasa.gov or whatever, registry.nasa.gov or whatever it is. You could say, if it doesn't exist here, you can't use it. And we started going down that road, but there wasn't enough use at LASP at the time to say, okay, we need to make copies of the images that we've decided are vetted. That might be something we need to revisit, because now we've got more and more teams coming into Docker, and they're basing their images on, you know, who knows, Ubuntu. I don't know what all the images are built on. You can see here we've got dozens of images pushed up to our local registry, because these are all sort of web team, the team that we're on. We have an insight that most of them use Alpine, or they use, what does Lattice use?
It's a
Column?
Jetty. It's a Jetty based.
So they've got a Jetty image that they use, but we've really only got a few base images that our team uses. But yes, if you are concerned about making sure that the images that people build from have been more vetted, maybe you want to use only SE Linux, or, you know, something that's been hardened a little bit more than just any old image, you could set up like a Nexus manager and say this list of images is all you can use to base from. And yeah, for security purposes, I think that's a really good idea. It's just additional overhead on your sysadmins or whoever it is that has to vet those images and decide, okay, Alpine 3.7 is allowed, whereas like maybe a CentOS image or whatever it is not.
There's also, so security, yes, but I also raised the issue that there's also the issue of licensing, right? So many of these platforms, certainly GitHub now and others, and Nexus has a plugin, I think, that it'll descend through the licensing of the software. And so it'll trace out your third-party dependencies and see if you're in violation in any way, which I know it sounds irritating, but is extremely useful from the agency standpoint of we can't roll out software that depend on proprietary software. We want to remain an open source community. Right. And so these platforms can do that. There is a Nexus platform at the agency that vets containers, and I'm going to be on a call later today to talk to them about it, but we could copy those containers and make them available to this community. And maybe there is also value in having a license checker capability of some kind.
Well, certainly,
to trace out our software stack to make sure that we're all kosher.
Yeah, definitely. That sounds fantastic. I'm a big proponent of automation. So anytime you can run software to do all that vetting instead of having someone spend a couple hours trying to dig into each piece of software and check the licenses, that sounds fantastic to me. Other questions about Docker, when you might use it? Anything else? This was just sort of I'll call it an executive overview. Docker provides a lot more functionality than just this stuff, but this is a good just introduction to what some of the main benefits are.
If no one else has a question, I had one more.
Sure.
Sorry, I heard someone else. I want to prioritize, not me.
No, you go. I just talked.
Okay. So that going back to the Docker file actually, and what you can specify in there. I've been using a tool called DeepNote, which is kind of like running Jupyter notebooks, but in a collaborative way, so that you have like that Google Doc style, everyone can work on it at the same time kind of thing. And they actually have an option to upload a Docker file to like kind of set up your development environment for that whole thing. And I never quite knew exactly what a Docker file could specify, so I hadn't looked into that. Remind me, you had said it's like basically a base operating system and then like kind of any commands you feel like you need to run to get stuff installed. Is that right?
Exactly. So like I said, we're using Alpine, which is just like super minimal. It gets you a shell. It doesn't have a C compiler. It doesn't have your Python interpreter. It doesn't have, whatever libraries that you needed for this particular application. So yeah, you have your base image, which you might use a Python base image. I actually just searched. It looks like some sort of DeepNote Python image in Docker Hub. So maybe someone has already done that particular piece of work and you can just run DeepNote. But yeah, it's essentially just some baseline. It could be in Ubuntu, it could be Alpine like we have here, it could be SE Linux. I'm not sure if there's a Windows one. I think I've seen, anyway, but then it's just a bunch of steps. So it's APK is the package manager for Alpine. So if you're used to Debian or Ubuntu, it would be apt-get. So you just run your apt-get installs, whatever packages you need. You could run shell scripts, you can copy file. I mean, you can, yeah. So it's essentially start from a baseline and then just whatever commands you need to get the environment set up such that it'll run your software. You can do that.
Nice. So a platform like DeepNote or maybe Binder or some of these other online host your notebook places are offering a place to upload the Docker file. They're kind of saying you can customize it to your heart's content, aren't they?
Exactly. Yep. And
nice.
Not only that, but you can customize it, and whoever else runs the image based on that Docker file will have exactly the same environment that you've specified for yourself.
Very cool. Thank you.
Yep. Other questions?
I had it's not a question, more of a comment. Well, maybe it's a question. Does this community have a shared CI/CD kind of environment? So you can combine that with containerization to target a number of OS platforms. So you basically, as a community, start saying, well, let's distribute the base images for the following Linux OSs. And you write your code, and then the CI/CD will essentially then take that container, wrap it with another container, and then execute a number of integration or unit tests, which we find are standard, and then it can report back. And so if there's anything that's OS specific that's going to pop up to wreck your code, we'll catch it early. You know, every time you're making a code commit, it goes through and does something like this. Do you have functionality like that already, or is that of interest? Or
We don't.
That sound like too
one thing I want
complex?
to clarify though too is that it sounds like you're talking about maybe the end user is using different distros. Oh no, okay. So you want Docker images that are based on these different distros. No, we're not doing anything like that on our team. I'm not sure that the heliophysics community has anything like that shared infrastructure that they're using. But yeah, that's a good idea too. The nice thing I will mention is that regardless of what distro you're running Docker on, it will still use this Alpine stuff. So say I'm using Red Hat or I'm using Ubuntu, as long as I have Docker installed, that's not going to impact what this container is doing, which is running a sort of a virtual Alpine, just to be clear. We haven't found a need to build images based on different distros like you're describing, but that could certainly be helpful, yeah, in the case of CI/CD.
I think between the Linuxes, it's kind of a slim margin. There's a lot of effort there and little payoff. But Docker, I believe, now handles Microsoft images.
I think
So-
I'm not sure. I have never
heard that.
needed to build to Windows-based environments, so I'm not sure. But I know that's they're trying to get all environments into Docker, so I wouldn't be surprised if you can run sort of Windows applications in there now.
And same for Mac OS. Although I can't confirm that, but if that were the case, then that would make that use case maybe a little more valuable, right? Because it's on an
Yeah,
OS.
then you could make sure your
directly.
software, yeah, could also
Right.
work on a Windows-like environment. Yep, and then that would, I'm just making off the cuff here, but that would be like, from Windows 11 or whatever the latest Windows 10. And then it would still execute. Now, yeah, in that case, that would make this a lot more interesting because I'm not, RM's not going to work in a Windows-like environment. So some of that stuff would, yeah, like you're saying, add overhead or complexity. We haven't found that use case at LASP yet, but if we do, Docker sounds like might be able to support it. Other thoughts? All right, well, that's just a quick overview of Docker and what it brings to the table. I'm a huge fan of it. I've been working at LASP for 5 years now, and I think when I started on this web team, there weren't any Docker containers. You pretty much had to know all the system administration stuff. If things started breaking, you had to really manually do a lot of stuff. But once we got into Docker, it was just like, well, just redeploy the container and now it just runs. So it's gotten so much easier. We only have, right now, only 2 people working on our Docker infrastructure full time. And we have at least 50 containers, maybe 100 containers running. And it's certainly less stressful than when I started. So when I started on the team, when things went down, it was a huge, you got a headache immediately. Something wasn't working. There was no easy way to just diagnose stuff. Now, once everything's in Docker, you can sort of say, well, I know when I run this container on my local machine, it just works. And a lot of times the solution is just restart the Docker container and everything fixes itself. So I can't say enough good things. It has lowered the stress dramatically on the system administration guys because you don't have these situations where there's all these dependencies sort of cloudering each other. It's all nicely packaged so that we know this piece of software, everything that's needed for it is just contained within this one small environment. So it's a really nice tool to use. You know, you really only have to learn Docker files, and that's like the big step from no Docker to Docker is just, in the case of this Flask app, it's 13 lines of, you know, fairly readable instructions. So yeah, that's Docker in a nutshell. Very useful tool to use. It really helps the system administration people. It really helps keep your dependencies all clean. And it's really nice to be able to just say, hey, Sean, I pushed up a new tag of this code. Can you run it real quick and make sure it, you know, checks all the boxes or whatever it is. And he just needs to run one command and has all the latest code and dependencies and everything right there without impacting his own system.
Yeah, thanks a lot for this, Fernando. And it's funny that you use us as an example, because I've been working with you for these years and seeing the evolution, but it still helps me to watch this talk and remember like what's actually happening underneath the hood a little bit.
Yeah, happy to do it. So yeah, you can, Sean will send you my contact info if you have any more questions. I'm happy to chat or answer questions over email or anything like that. Just shoot me a line. Sean has my contact info. So yeah, let me know.
Yeah.
Thanks, everybody.
Awesome. Thanks so much, Fernando.
Yeah, no problem.
Yeah, super appreciated. Well, let's see. The only extra info I have to say is that our next telecom will be Monday, September 13th, same time, same place. I figured it's been a little bit, so we could take that time to continue our discussion we had from the May 24th telecon, where we talked about decadal survey white paper brainstorming. There is a Google folder for that where we started idea genesis, and I'll link that in the notes from today for people to look at before that happens. So if no one else has anything to report, we can go ahead and wrap up. Oh, we'll wrap up. Thanks,
Wonderful.
everyone.
Yes.
Thanks, y'all.
See y'all.
See you all next time.